Welcome back to Virtual Algebra 2. This is part 3 of section 4.3, matrix division. As you can tell by my hat, it's winter here. We're in the northern hemisphere. We're upside down from you guys. It's kind of cold. Alright, so finally we're going to get to see why I've been calling this thing matrix division. Okay, what we're going to do is we're going to solve an equation like this. But it's a matrix equation. Okay, so A is this matrix here, 2, 3, 3, 5 that we've seen before. X, our unknown, usually that's our symbol for our unknown, right? X actually represents a matrix of unknowns. Here there's two of them, X and Y. And C is sort of a fancy number, a matrix on the other side, 1, 1. Right? So what we're doing is we're looking for the values of X and Y that will make this matrix true, that make this matrix equation true. And you can probably think about it and work it out and trial and error and figure it out. But using the skills we've just learned with identity matrices and inverse matrices, we can solve this a different way. Okay? So I just want to make an analogy with the problem like this. 7x equals 24. Well, we all know how to solve that. We've known that for years. Some of us might say divide both sides by 7. Alternatively, you could look at it as multiplying both sides by 1 over 7, the inverse or the reciprocal of 7. Okay? And if we do that, 1/7 of 7x turns into just x. And that's the key, right? We get x alone by using that inverse trick. And then over here, something happens, whatever it is, we have to live with it. 1/7 times 24 is just 24/7. Right? So the same kind of idea here. So this is basically like division, right? And it's kind of the same idea here. And what is exactly the same about it is what we're going to do is multiply both sides by the inverse of this matrix. Okay, now last time I didn't tell you how I figured it out, but I did tell you that the inverse of that matrix was this guy, 5, -3, -3, 2. I'm not going to have enough room if I leave this up here. It's not so important anymore. Okay, so that's multiplying the left side by the inverse of that matrix. Well, to be fair, as always, I have to multiply the right side by the same thing. And that's actually where all the interesting magic happens. Okay, so what happens here? If I multiply this matrix times its inverse, what's that going to make? A matrix times its inverse always gives you the identity matrix. Okay? If you don't believe it, go back and try it again, but this times this should give us this. Now what happens over here? See if you can figure out this matrix multiplication on your own. Pause it and see if you get the same thing that I do. And what do I get? Is that right? Yeah, that's right. Okay? So what I end up with when I multiply both sides of this equation by the inverse of this is I end up with this. Now this is kind of like saying 1 times something equals something. We don't really need this anymore. The identity matrix times the matrix is the same thing as just the original matrix. Okay? So we've solved this matrix equation by using this trick of multiplying both sides by the inverse. And our answer is that x is 2 and y is -1. Now this matrix equation actually is the same thing as a system of 2 equations and 2 unknowns. And soon we're going to learn how to see that connection. But what we've done here is, using an inverse matrix, we've solved that system very easily. Okay, so the next step for us is to figure out how to find the inverse matrix. So far, I've just given it to you, right? You didn't have to find it. What I wanted to do here was just to show you that knowing how to find the inverse might be a good thing to know. Because if we can do that, if we can figure out how to come up with an inverse like this, then we can solve this kind of equation really easily. It's important to remember that we have to multiply both sides by the inverse matrix on the left. If we tried to multiply on the right, we know that multiplying on the right and on the left, we don't always get the same thing with matrices. They're not as easy to deal with as just numbers. In fact, we couldn't multiply this times this in that order, right? If we put this matrix over here, it just wouldn't be defined. So we have to be careful to multiply on the left by the inverse matrix, okay? We're going to come back to this again, but I just wanted to motivate some hard work to come in finding inverse matrices, because doing that is a little bit tricky. Alright, so that'll be the next segment of this part. So, if you want to find the inverse of a 2 by 2 matrix, here is the secret method, yeah? If the matrix is capital A and it has elements little a, b, c, and d, then what you have to do is first find this crazy thing, a times d minus b times c. That thing, which is underneath a 1, is called the determinant. Okay, it sounds an awful lot like discriminant, but it's not exactly the same. It's called the determinant. And for a 2 by 2 matrix, the determinant is just a times d minus b times c. Okay, then we're going to do 1 over that. Alright, so whatever that number is, maybe that number is a 4, then we'll have 1 over 4. And then that's times this matrix. Now compare this and the original. A and D have swapped places, so D's up here and A's down here. And B and C stay where they are, but they get negatives put in front of them. Okay, so that's all you have to do. We're going to do an example here with this matrix 1, 2, 3, 5. So the first thing we should do is find the determinant. So you try it. What's the determinant of matrix 1, 2, 3, 5? Okay, well it should be a times d, 1 times 5, minus b times c, 2 times 3. 1 times 5 minus 2 times 3. That's 5 minus 6. That's negative 1. Okay, so we found our determinant. It's negative 1. So the first part of our formula is just 1 over the determinant. 1 over negative 1. Now what happens in here? A and D need to switch places, and B and C need to become negative. So instead of a 1 up here, there's a 5 up here. And the 1 goes down here. The 1 and the 5 just switched places. The 2 and the 3 stay right where they are, but they become negative, right? Okay, we're almost done. The last part is to figure out what to do with this. 1 over negative 1, that's just negative 1, right? Negative 1 times 5, negative 2, negative 3, 1. Now this is a scalar multiplication. We know what to do with this. This just means that every number in here gets multiplied by negative 1. That just changes the signs. And our final answer for the inverse of matrix A, if this is matrix A, is this. Okay? So finding the inverse of a 2 by 2, it's a lot of work, but it's not so hard. Okay? Now how can we check to see if we got it right? How should we know that this is the inverse of this? Right. We need to multiply them together and see if we get the identity matrix. Let's try it. 1, 2, 3, 5, negative 5, 2, 3, negative 1. Okay, so try that multiplication yourself right now and see what you get.